Hello and welcome again as we look at yet another multiple choice question for IB Chemistry. Which combination shows a second order rate expression with the correct rate constant units? Now, the only way to determine the order of a chemical reaction is by carrying out an experiment. But of course, once that experiment is carried out, then you establish the rate expression or the rate law. And from that rate expression or rate law, it's possible to determine the order of the reaction. So let's look here at these four expressions for the rate. Here you can see that the rate is equal to K, the rate constant, multiplied by concentrations of two entities. That would make it a second order reaction. So A is a second order reaction. B, of course, with just the one molecular entity multiplied by K, that's a first order reaction. And the same for C. So we've eliminated B and C without even considering this column here. Now D shows rate equals K multiplied by one molecular entity, another molecular entity, and here I2 is included, but look here. It's raised to the power of 0, which makes it 1. Any number raised to the power of 0 becomes 1. So in effect, rate here is equal to K multiplied by entity 1 raised to the power of 1, entity 2 raised to the power of 1, making this a second order reaction. So now we have two second order reactions, D and A. The second part of the question, of course, requires us to have the right units for K. And figuring that out is going to allow us to separate A from D. To do it, you could, of course, memorize the units for a second order reaction. And if you memorize it, you would know that it's this, dm cubed per mole per second. But I don't want you to have to memorize that information. So let's quickly take a look at how to derive the units of a second order reaction. First of all, the unit of rate would be moles per dm cubed, the unit of concentration, per unit of time, which is the second. So moles per dm cubed per second. It could also be written like this. So with this unit for rate, if we have a second order reaction, it means rate equals to K, which will have to have units, multiplied by concentration of entity 1 in moles per dm cubed, and that multiplied by concentration of entity 2 in moles per dm cubed. And then bear in mind that the answer must come up to moles per dm cubed per second. So it means that when this is multiplied by K, that you have to end up with moles per dm cubed per second. So it means then that K would have to have something in its numerator to cancel out one of these dm cubes. So K is going to have to be dm cubed at the numerator, and that already confirms for you that D is the answer. But let's get the rest of it. It would also have to have something to cancel out one of these moles from here. So that would mean that mole would have to come here in the denominator. So dm cubed per mole, and then of course the per second, which is not even on this side, it's on that side. So that would also have to be included in K, multiplied by 1 over second, which gives dm cubed per mole per second, an answer of D.